Hello fellow students, welcome to MathWorks Tutorials. My name is Mahiman. I am paired with my fellow teachers Mr. Caleb and Mr. Dami. Today in our tutorial, you'll learn the dynamics as well as the understanding to prepare for your diagnostic unit in grade 11 functions. This will not only prepare you for the diagnostic test, but will help you prepare for the whole course. In the tutorial, you will learn the understanding different concepts of the unit in sorts of ways such as tips, tests, assessments, knowledge, thinking, application, and communication, and it will be shown in various types of medias such as graphs, word problems, and equations, and many more. Hope that you learn and understand what the concept of the diagnostic unit is and what it is to help you succeed throughout this course. Stay tuned and enjoy. Hello class, I'm back with the tutorial. So now in the diagnostic unit in chapter 3, it is on expanding binomials and completing the square. First off, I'm going to go on with expanding binomials. So I'll explain you what expanding binomials really is. So in terms that in mathematics, an expansion of a product of sums expresses it as a sum of products by using the fact that multiplication distributes over addition. The expanding of binomials can be obtained by multiplying each term in the first binomial by each term in the second binomial. Then you can simplify by collecting the like terms. So as I tell you what that means, I'll explain that through doing these examples. So you are given these two equations, this one equation. In this one equation, you have two brackets. So what do you want to do? You want to first get the first binomial and distribute it to the second one. So you can do that by first x by multiplying the x and the first term in this binomial, multiplying it to the first term in this. Then you want to multiply it to the second term in the second binomial. Then you want to do the same for the bottom part, and you can do it for this part as well. So I'll be showing you that this will x times 2x, so you basically want to multiply it. So x times 2x is going to be 2x squared. Now x times negative 4x, you're going to get you're going to get negative 4x. And now you do the same for the second term and the binomial, and you multiply it to the second binomial. And when you multiply this term to this term, you're going to get 2x plus 2x. And now when you multiply 1 times negative 4, you're going to get left with negative 4. Now that we have expanded this, we need to simplify it. And to simplify it is by adding the like terms. So 2x squared cannot be added to anything, so you leave 2x by itself. Then you see what else can be added. So negative 4x and 2x can be added into each other, so you add them. So you're going to be, not that. So now you're going to be left with negative 2x, because negative 4 subtracted by positive 2 is you're going to be left with 2x. Then you just take down the 4, because it cannot be multiplied into anything else, so you leave it as that and you make it come down. And therefore this is your final answer. This is the method known as FOIL, where you multiply the first term to the second binomial and to the last, in the second binomial to the last term in that. And it's basically like shaped as a foil, and you memorize that. And this is just a little picture that explains this. And you guys just need to try memorizing it. Alright, so I'll now be moving on with the next equation. Okay, moving on with the next one. So you want to do the same thing as we did here with the first two binomials. Then we can work on with the third binomial. So you want to do the same thing as you did. The first step you should memorize and write this down in your notes so you can keep on remembering it. Take the first term in this binomial and multiply to that, and then you multiply to that, and then you multiply this to that, and that to that. So basically, you take the first term in this binomial and multiply to the first term in this binomial, and you can do the same to the second one, and the second term in this binomial to the first one, and that one to the second one. And let's simplify it. So you're going to be left with x squared, negative 4x, and you're going to multiply this, so you're going to be left with plus 2x. Then you multiply this, so you're going to be left with negative 8x. 8, sorry, my bad. Alright, so now you just add these two up, and this is going to come on the side, this is just going to come down. So now we need to simplify this part so we can get on by expanding this. So I'll be back. So as you simplify this, we need to add this into that, so we'll be left with negative 2x and subtract by 8. And the way we need to do that is by taking all these three terms and multiplying it to the same way we did that, as we did over here. So even if there's three terms, you can do the same thing by expanding this binomial. So I'll just write this down. So what you want to do is first you want to multiply this term to this one. So you're going to get 4x cubed. Because when you multiply like the squares, you add them. That is the exponent law. So now you take this one and multiply this. So you're going to be left with negative 3x squared. Now you move on to the second term in this equation. So you take negative 2x and multiply by this, so you're going to be left with negative 8x squared, because x times x is adding the two things squared. Now you take the third one and you multiply it between this and this, so you're going to be left with negative 8 times 4x, which is negative 26. Now you take the negative 8 and you multiply the negative 3, so negative 8 times negative 3 is going to be positive, because negative times negative is positive, and that will be 24. And now we need to simplify this, so it's going to be 4x cubed, be 11x squared, and then these two come down here, and that is your final answer. Alright guys, I'm back with the tutorial, and we are in the second part of completing this square. So as we found out the fundamentals of expanding binomials, this leads to the topic of completing the square. So as we know that completing the square, you need to use and recall that the quadratics can be written in two different forms. Now, before I get into the topic of completing the square, I want you to understand what this actually means, what this topic of completing the square means. So basically, completing the square means, and the reason we do that is because when we try to solve quadratic equations by completing the square, it is overpowered by an offspring of doing this process, namely, it is the quadratic formula. The quadratic formula was derived by completing the square on a quadratic equation. And the reason we do that is because we need to recall by writing down the two forms, which is standard form and vertex form. Now I'll be going in depth between these two forms and how we actually do completing the square. So as I was talking about the two forms, which is standard form and vertex form, to be completing the square. So in standard form, you're given this equation y is equal to ax squared plus bx plus c. So in this equation, we see that there are certain rules to this. So in the standard form, when a is less than 0, then it is reflection on the x-axis. And if A is greater than 1, then there's a vertical shift. And if A is greater than 0 and 1, then it is a compression. So it would be, if it's 1 over 2, or if it's 2 over 5, and etc. And y-intercept is equal to c. So now these are the certain rules for a standard form, and you'll be using this when you are completing the square, and when you're converting the equations from standard to vertex, or vertex to standard. So and that's what these rules are for. Now for the second part is for vertex form, and the vertex form formula is y is equal to a bracket x minus h bracket complete 2 squared, plus k. So what this is the same thing, the same rules as we learned from above, but now that reflection in the x-axis if a is less than, if 0 is greater than a, then it's a reflection on the x-axis, and the other one it is opposite. Now moving on to the next part, it is if k value is greater than 0, then it goes upwards. If k value is less than 0, then it is going downwards. Example, if k is negative, then it's going downward. If k is positive, then it's going upwards. Now vertical stretch, if a is greater than 1, then it's a vertical stretch, and if it's between a, then it's a vertical compression. And the vertex is at h and k. So make sure you know this formula for this. And the k represents the vertical translation. If k is greater than 0, then it moves up, and if k is less than 0, then it moves down. And those are the certain amounts of rules for vertex form. Also, that the h represents the horizontal translation. So if h is greater than 0, then you move right. But if 0 is greater than h, then you move left. Note that the negative sign behind h, the negative sign is the key. So if it basically tells you if it's greater or not. And that's what you should remember throughout all these formulas from the standard or the vertex form, and that will help you out. So I know completing the square might be a little difficult from learning all those rules. So I'm gonna make it easier by making these 5-6 steps. So basically, I thought of these 6 steps, and I'll go over them, and I'll just explain a little bit. So the first step you want to do, and also you guys should be writing these down so you can memorize them. So the first step is group the x terms. You want to group those, and you want to not factor them at first. You want to group them up so you can have those sections ready for the next part. So the second step is that common factor out the value from the x terms. So as you take that, you take the common factor from the x terms. So now you're set with these values. Then 3, you want to divide the coefficients to the middle term by 2, then square it. Then you want to add that and subtract that by the number inside the bracket. I know that might be a little hard to take in, but I'll teach you as I go in with examples. Then step number 4, you want to remove the subtracted term from the brackets. It may be multiplied by the value. It is multiplied by the value. In step number 5, you want to factor and simplify and solve for x, and that's when you're going to get the equation on the board right now. And now I'll be going over a few equations as well as a word problem. Okay, so we'll be now moving on with the second question. So it says, convert to the vertex form. State the direction of the opening, the vertex, whether the function is a maximum or minimum, or minimum value. So now, and the equation is negative 3x squared subtracted by 6x minus 5, and I'll be doing it over the quadratic way of, from the way of completing the square. So now I've listed down all the steps. I've solved it for you guys because it'd be easier seeing it the first time. So the first thing you want to do is group the x terms. So that is grouping negative 3x squared plus negative 6x and leaving negative 5 on the out. And the second thing I told you you guys should do is make sure the leading coefficient of the x squared is 1. So you want to factor the 3 out because the a value has to be 1 and it can't be negative. So you take the negative 3 and you factor it out and you're left with negative 3 bracket x squared plus 2x minus 5 outside of the bracket. Then the third step is look at coefficients of x as you see that and divide it by 2 and you're going to be left with plus 1 and negative 1 as you see in the equation. Then you take the three terms and then you solve it by grouping it. So it would be negative 3 bracket smaller bracket then x squared plus 2x plus 1 then bracket complete, then subtract by 1 and then overall bracket and then subtract by 5 out of the bracket. And then you're left then you're supposed to multiply the negative 3 into the brackets and then you're left with negative 3 bracket x plus 1 bracket complete squared plus 3 minus 5, and then you just take the 3 and add it to the 5 and then you're left with negative 3 bracket x plus 1 and then bracket complete 2 and then negative 2, and the vertex is stated that it is negative 1 and negative 2, and the parabola opens down and has a y-intercept at 0 and negative 5, and this can be all done by the rules I told you about in the standard and vertex form. So now I'll be showing you how I drew the graph for this equation. So as I said, the graph is going down because the a value was negative, and now you just have to find the two intercepts and then you just plot the graph, and this is how it will look like. I tried to make it look nice, but the online software didn't pull off that well, but this is what I got. It looked a little better, but I'll be now moving on with the next unit. Now guys, this basically winds up the expanding binomials / completing the squares section of Unit 3 in the Diagnostic. And now, hopefully you learned these concepts. I'll be putting a link right here about the test. I'll give you a test because in this whole unit you won't be given any assessments or anything because this is a diagnostic. You're observing what teaches what your skills are for this next upcoming course, grade 11. So you won't be given any test or anything. You will be given a test, but that won't be going to your final mark. So I'll be giving you a test so you can practice, and I'll give you some tips questions so you can prepare better. So thank you. Alright guys, I'm back with the next chapter in the diagnostic unit, which is on chapter number 4, solving with the quadratic formula. This is a pretty short unit, and it's basically using the quadratic formula to solve standard form. So as we talked about that in the last chapter, the rules for it, I'm going to be showing you another way to solve the standard form formula. So oftentimes, the simplest way to solve the standard form formula for the value of x is to factor the quadratics, but it's factoring may seem pretty hard and it may wind up to a lot of steps, and that may lead you to some mistakes which can make you lose some marks. So the easiest way to that is the quadratics formula. You can do factoring, but it's easier to do quadratic formula because it's uh, less hassle, and it's cleaner basically, and it's easier for the teachers to read. It uses A, B, and C from the from the standard formula, and where A and B and C are just numbers, they are the numerical coefficients of the quadratic equation they're given to solve. Here's the formula. So x is equal to negative b, so you take the b and you turn into negative, plus or minus, then square root b squared subtracted by 4 times a times c, and divided by 2 times a. So this is the quadratic formula. Now I'll be going in depth with one or few examples. Okay, so I got this equation. So it's 5x squared plus 6x plus 1 is equal to 0. So we have gotten this standard form equation, and we need the first step, I would say, is lay out the coefficients. So your a value is 5, your b value is 6, and your c value is 1. Now we know the basis of our coefficients. Now we just need to replace it into the quadratic formula. Now recalling, the quadratic formula is b minus negative b plus or minus a square root bracket b squared minus 4 times a times c, bracket complete, divided by 2. Now you just replace the coefficients. So you put in b into the first spot, and you make it negative because that's what it said in the formula. And you do plus and minus bracket, square root, then bracket, then you replace b with c, and then the 6, then you put the squared on it because that was in the formula, then subtract it by 4 times a, which is 5, times c, which is 1, then bracket complete, and divided by 2a, which is 2 times, this is divided by 2 times 5, because 5 is 8. So now you got the logistics. Now you just use BEDMAS and solve through it. So first thing is, you need to work through the bracket, and in the bracket, after you do square of 6, you're gonna get 36, and 4 times 5 is 20, times 1 is going to be negative 20, so 36 minus 20 is going to be 16, and then the negative 5 and negative 6, which is b, is still going to stay as the same, and you do 2 times 5 at the bottom, which is 10. Now you just wind up what is in the bracket, which is 36 minus 20 is going to be 16, and there's the square root. So now there could be two possibilities. I know I did this on the computer, so it was hard to see that there's two possibilities, but when you're writing it down, you want to put one arrow on the top and one arrow on the bottom, because do you see that plus or minus? That is depending on the positive of the quadratic formula and one for the negative. So first you want to do the whole equation. So as we got the negative 6 plus or minus square root bracket 16 divided by 10, you want to do it plus, you want to replace the plus or minus by only plus and making it go up. And then for the second one, you want to replace the plus or minus with negative and our arrow going down. So when you do that for plus, you're going to get negative 0.2, and when you do it for the negative, you're going to get negative 1. And this is your answer. And this is what you would write when you are given the quadratic formula. And that basically winds up this chapter, because this is so easy, guys. You just take the coefficients and you replace it into the quadratic formula. That's it. It's so simple and sweet. And most of the problems will be simple and short like these. And you just need to make sure that you do the key process slowly and carefully, and you don't mess up, and you make sure that you do BEDMAS. You don't just simply randomize it. you make sure you do bed math because that's really important. And that's basically it for this chapter. So I hope you guys learned, and thank you.
Hello everyone, today we will be talking about primary trig ratios. And first of all, we need to know about our Pythagorean theorem. So in any right triangle, the hypotenuse squared is equal to the sum of the square of the two other sides in the right triangle. From angle theta, we opposite the angle theta will be the opposite, and then going down from that will be the adjacent, and then of course we have the hypotenuse. The three trigonometric ratios that we should know are the sine A, which is equal to opposite over hypotenuse, cos A, which is equal to adjacent over hypotenuse, and tan A, which is equal to opposite over adjacent. And the easy way to remember this is SOHCAHTOA. So stands for sine is equal to opposite over adjacent. Ka stands for cos is equal to adjacent over hypotenuse. And toa stands for tan is equal to opposite over adjacent. Sine law, cosine, and tangent. Now we're going to talk about angle of elevation and angle of depression. An angle of elevation is an angle from the horizontal to the line of sight. So you looking upwards. For example, you're looking at a building. The angle of depression is the angle from the horizontal to the line of sight. So for example, you're looking downwards. The angle from your line of sight to the building you're looking at below you is your angle of depression. And same as angle of elevation. In this example, we're going to be looking at how to solve for x. So in order to solve for x, we need to find the formula that gives us a known measurement and the x. So in this case, a formula that works is tangent, and that is equal to opposite over adjacent. And then in order to get to solve for your x, it'll equal tan 37 is equal to x over 8. In order to continue to solve that, you have to cross multiply. When you cross multiply, you get 8 times tan. 8 times tan 37 is equal to x. When you plug that into your calculator the exact same way, that should give you 6.02. And we do tan 37 because you need to take the known angle, not the 90-degree angle, the 37-degree angle, as shown in the triangle. In this example, we're going to be solving for the angle theta, which is inside the triangle, not the x that's outside the triangle. For this, we need to find the formula that gives us the measurements of the two known sides. And instead of making it equal, instead of making the formula with a angle, we're going to make it with theta. As shown in the picture, it says cos theta is equal to adjacent over hypotenuse. Our adjacent and hypotenuse are known, so we plug those in, so it goes into cos theta is equal to 5 over 24. In order to get the angle, we need to do something a little different, and we need to inverse that. When we inverse that, that gives us the angle inside the triangle. So we plug cos inverse 5 divided by 24 with brackets in our calculator, and that gives us a theta angle, which is 77.9. In this example, the triangle is not given to us. We have to draw a triangle from the word problem. So as we get our numbers from the word problem, we have to draw the triangle and solve from there. So in this, we're solving for x. We have to find a formula that gives us a known side with the x. So therefore, this formula was tangent. So we say tan 23 because the angle in the triangle is angle 23. We say tan 23 is equal to opposite over adjacent. We plug in our values, which will bring us to tan 23 is equal to x over 300. We cross multiply, which gives us 300 times tan 23, which is equal to x. That final answer then comes to 127.3 is equal to x. In order to make our triangle from our word problem, we need to take our measurements from our word problem and plug them into our triangle. Hello everyone, and in this lesson we're going to be talking about exponent laws. As it is shown in the picture, the number 8 is the base and the number 2 is the exponent, which can also be called the index or the power. Here are the exponent rules that need to be known. The arrows that point upwards indicate the numbers being changed to an exponent. So the number 1 is the zero exponent rule, which states that a exponent 0 is equal to 1 because a cannot be 0. Number 2 is the multiplication rule. A exponent b times a exponent c will equal a exponent b plus c because all you have to do is add the exponents if the bases are the same. This is number 3 is a division rule. It states that a exponent b divided by a exponent c will equal a exponent b minus c because when you're dividing exponents to the same base, you just minus the exponents. Number 4 is a power of a power rule. So in brackets, if you have a exponent b and outside the brackets you have an exponent c, that will equal a exponent b times c. Number 5 is a negative exponent rule, which means that if you have a exponent negative x, that means you have a negative exponent. All you have to do is it'll equal in brackets 1 over a, outside the brackets is your exponent x. And making it 1 over a causes the exponent to change to a positive. And therefore you can simplify or solve and evaluate whatever you need to do. And also your a cannot be 0. In this example, we're going to be simplifying 2x exponent 7 in the brackets and outside the brackets exponent 3. In order to simplify this, we multiply the outside exponent in, which becomes 2x exponent 7 times 3. And that simplifies to 2x exponent 21. In this example, we're going to be solving a exponent negative 5 divided by a exponent negative 8. And for this, we're going to be using the division rule, which means because they have the same basis, which is a, all we have to do is bring them together and make it a exponent negative 5 minus negative 8 in order to further simplify. And that will bring us to a exponent 3. In this example, we're going to be solving 2x exponent 2 times 4x exponent 3y. So what we have to do, because we're going to be using the multiplication rule, all we have to do is add exponents with the same bases. So what we do is we multiply 2 times 4, which gives us 8. And then after that, we can move to the x's. All we have to do is add the exponents. So all we have to do is 2 plus 3, which is 5. So that'd be 8x exponent 5. And since we only have one y, there's nothing to add to that. So we bring the y down, which would give us 8x exponent 5y. In this example, we're gonna be simplifying negative negative open bracket 4a exponent 3 close bracket exponent 2 divided by a exponent 5. So what we first do is we multiply the exponents together, which will bring us to negative open brackets for a exponent 6 close brackets divided by a exponent 5. And then we bring the negative on the outside of the bracket inside, which will bring us to negative 4a exponent 6 divided by a 5. So what we do is we first of all divide the bases, which would be 4 divided by 1 will give us negative 4. And because the exponents have the same base, we just minus exponents because that's a division rule. So it'd be 6 minus 5, which would bring us to 1. And our final answer would be negative 4a exponent 1. But because it's an exponent 1, we don't exactly have to write 1. Exponents, if there's no number written, it's assumed to be 1. In this final example, we're going to be solving open bracket negative 2x exponent negative 3 y close bracket another open bracket negative 12x exponent negative 4 y exponent negative 2 close bracket divided by 6x y negative exponent negative 3. But we all know that the x, if there's a number written there, we know that it's a 1. So for this, first of all, what we have to do is we multiply the numbers, which is negative 2 and negative 12. We multiply negative 2 and negative 12 because they're both negatives. That becomes positive, which will bring us to 24. We go to the x now. Because they have the same basis, we add exponents because it's the multiplication rule. So negative 3 plus negative 4 will bring us to negative 7. So far we have 24x exponent negative 7. And now we move to the y, which would be, because we're doing the multiplication rule, it'll be 1 plus negative 2. Because it's said that if there's no number written in front of the exponent, we assume it's a 1. So that'd be 1 plus negative 2, which will bring us to y exponent negative 1. So right now we have 24x exponent negative 7, y exponent negative 1, divided by 6x exponent 1, y exponent negative 3. And now what we can do is divide the numbers, which is 24 and 6. That'll bring us to 4, because 24 divided by 6 is 4. Now we move to the x's again. Now we're at the division rule because now we're dividing. So what we do is we minus exponents. So exponent negative 7 and exponent 1, we minus those. So negative 7 minus 1 will bring us to x exponent negative 8. And then we move to the y because we're dividing. We have to minus exponents, which would be negative 1 minus exponent negative 3, y negative 1 minus y exponent negative 1 minus y exponent negative 3, which will bring us to 2. And our final answer will be 4x exponent negative 8 y exponent negative 2.
Alright guys, thank you so much for paying attention throughout the whole tutorial. Hope you guys enjoyed and learned, and hope you guys bring success into your term as you do the diagnostics. Make sure you go through all the key lessons and go over them, do a lot of practice so you keep on succeeding, and this will give you a good boost while you go into the course of grade 11 functions. So once again, hope you guys succeed in this course, and thank you so much for paying attention, and make sure you just go over the keys. And that's it guys. If you have any questions, please leave a comment in the description and we'll try to answer it. Thank you guys so much, and I'll see you guys next time. Peace out.